Hello? Everybody can hear me? Hello? All right. I was watching that food line. I'm like, oh, we should start, but they need food. Otherwise, there'll be a revolt. So my apologies for starting a little bit late today, but welcome to the first 17, Enbridge Research in Action seminar series. We're very excited to have a great speaker today. First, I want to start by recognizing that we are on Treaty 7 land, the traditional land of the Siksika, Kainai, Piikani, Stoney Nakoda, and Tsuut'ina, a place that in Blackfoot, based on the elbow, is traditionally known as Mohkinstsis, and welcome you all here today for this great kickoff. I also want to recognize Enbridge for supporting the seminar series. It's been a great partnership, and we're bringing one more great speaker to you today. So thank you for coming. I want to reiterate that the slides will be up on our website in about a week's time. So if you're having a little bit of a hard time seeing from the back some of the graphs, don't stress it. You can download it from our website. So with no further ado, I want to introduce our speaker, Alan Fogwell. Alan is the president and CEO of CERI, the Canadian Energy Research Institute. He became president in 2014 in November. He has over 25 years of experience in both the public and private sectors. He has previously worked in the natural gas distribution companies, both in BC and Ontario, has a master's degree from Simon Fraser University in Natural Resource Management, and a Bachelor of Science degree from the University of Saskatchewan in Geography. Please join me in welcoming Alan Fogwell.
Hello, everyone. I'm just moving this. If you can't hear me, just raise your hand and I'll start talking louder. If you can't hear me and you don't want to, raise your hand and I'll stop talking. What I want to do today is to take you through a project that the Canadian Energy Research Institute started a few months ago, and it's to answer the question about electrification. Electrification has come up as a focus in some general discussions at the federal government level, and also in some discussions within the Ontario government, looking at ways to convert end-use energy services to electricity and in order to reduce emissions. The kind of services that we're talking about are in the residential, commercial, and transportation sectors. And what we're really trying to do is to give everyone a bit of an understanding of the complexity and the costs and the impacts associated with going down that route. Before we start, just let me say that the Institute doesn't take a position on whether this is a good thing to do or a bad thing to do. We put the facts out and let the decision makers, whoever they may be, use them to make decisions. We won't even comment on whether those decisions are good ones or bad ones. That's not our role. Our role is to give people information that they can use to make informed decisions. So our study is on greenhouse gas emissions reductions in Canada through electrification of energy services. A little bit about the Institute. We're a not-for-profit organization. We've been around since 1975. Our focus is on economic and environmental analysis of energy-related issues. We work with government, we work with industry, we work with the academic community and with other stakeholders to try and provide as balanced and as comprehensive a view on issues as possible. Right now, just want to put a tip of the hat to our sponsors. The Alberta government, the Government of Canada, the Canadian Association of Petroleum Producers, Chemical Industry Association of Canada, Alberta's Industrial Heartland, the University of Calgary, and the Korean Energy Economics Institute. They are our main sponsors, and we also have in-kind support from the Alberta Energy Regulator and the Petroleum Services Association of Canada. So, as I started out, we're looking at how we're going to go down a path to electrifying end-use services and what that means in terms of greenhouse gas emissions. The concept behind here is it's going to be much easier to consolidate all the point source emissions from all our homes and our buildings and our cars into the electrified energy grid and deal with fewer sources of emissions at the more centralized spot. We also wanted to make sure that we were using existing technologies. So this is not a future assessment about where technologies are going. These are technologies that are available to now or shortly, and that can be used throughout residential, commercial, and industrial sectors. This graph may be familiar to a lot of you, and it really goes to the push side of a greenhouse gas management scenario. These are graphs coming from the Intergovernmental Panel on Climate Change, looking at the level of carbon emissions or carbon factor that would be needed in order to reach some of our goals, the 1.5 degrees global temperature stabilization and the 2 degrees. The green line at the bottom is the line that represents the carbon intensity factor that's needed to meet the 1.5 degree goal, which means that we've got a long way to go if you look at where we're starting from, which is around 20 on the graph. There's another element associated with where we're going on electrification, and that's push. And the best example of push is in the transportation sector. We're getting lots of information, advertising, marketing from various companies on the use and benefits of going with electric vehicles. So you can see here that there's been a number of improvements in the number and design of vehicles available in the transportation sector. So we're getting the pull from a policy perspective, a policy goal, and a push from technology options that are available to solve some of those problems. So, what were the objectives? We wanted to really assess the economic and environmental impacts. And in this case, we're looking at what is the reduction in greenhouse gas emissions, if any, and what is the cost associated with converting residential, commercial, and transportation sectors almost all the way over to electricity. In this case, we've used a 90% factor to make sure that there still remains some of the old technologies that are existing today. We didn't include the industrial sector or freight transportation, partially due to data limitations and partially due to, in the case of freight transportation, the size of the market. I mentioned before about using feasible technologies, so those are involved. We're talking here about converting the electricity grid to something that's able to handle a much larger demand, so expansions of transmission, expansions of distribution, and of course expansions of generation. So for those in the room who are interested in the methodology behind this is one of 2 slides that we talk about the methodology. We can always have those conversations in the back of the room when everyone else has left. So we've used the stock turnover approach. So as equipment comes up for retirement, you look at the new equipment available, you're going to pick the electric version of that equipment choice, you put it in place, and that carries on. And you do that with the next one and the next one and the next one. And what we're doing is over every 5-year period of that 30-year horizon, we're changing the stock levels of these new technologies. Very simple scenario setup that we have right now. I want to make it clear that these are scenarios we're running, not forecasts, right? So in the case of, we've got a business as usual, where we are taking the electricity grid in each of the provinces as is with its current policies that are in place, and no changes to how companies and individuals and residences are using their electricity or other energy services. So that's scenario 0. And then the 2 other scenarios that we worked on was electrifying the demand side, residential, commercial, transportation, and then considering how they impact with the electricity grid, where you'll have a high degree of renewables on the grid, with the rest being, in many cases, natural gas, combined cycle turbines, plus a one where the natural gas turbines are assumed to have carbon capture. This is just a quick identification of how we've developed our stock turnover model for residential. You can see we have it with space heating and space cooling, water heating, and appliances. This is fairly basic when it comes to a stock turnover model. Similarly, in the transportation sector, you can see what we're using in terms of passenger transportation. It will include public transit, but it will not include freight. So this gives you starting to get into an illustrative look at what our analysis was showing. In terms of the top left graph, the stock, you can see how the stock changes over time from one that's based on natural gas to one much more focused on electricity. So that's the stock turnover that you see. The energy services themselves, the energy requirement, in this case is space heating, doesn't change. So we haven't got into the point of adding in new windows or insulation to reduce the amount of heating space that's required. But taking those 2 together, you get the energy service demand at the bottom. And key to that is that with most end-use service technologies, when you are replacing a fossil fuel-based technology with an electricity-based technology, you are going to get a significant increase in end-use efficiency. For example, if you're looking at heating in a home, you're going to go from somewhere in the range of 85% for a natural gas furnace to close to 100% for electric baseboards. Similarly, with water heaters, you can get 70% for natural gas water heaters, close to 100% for electric water heaters. Those inherent efficiencies are important when you consider the following results that we're showing you. So this just identifies that we've done full stock turnover with residential sector. With the commercial sector, because of the longer lead times with some of the elements, it's a partial stock rollover. The same with transportation. So let's get to the good stuff, the results. On this chart, what you see is a business as usual approach compared to electrification of the end use for Alberta, the Atlantic provinces, and Ontario. And let's just take Alberta to start off with. In terms of business as usual, you see that there's a fair amount of natural gas demand for residential end uses. When you electrify the end use in the residential sector, you can see that that natural gas demand diminishes significantly, electricity increases significantly, and the total overall energy requirement also decreases significantly. That goes back to the point I raised about the difference in end-use energy efficiency in the residential sector. Same is the case in Atlantic Canada, and the same is the case in Ontario. In Atlantic Canada, one should note, there's not much natural gas being used in the residential sector, still a fair amount of oil, and that is the group, or that is the energy type that faces the largest reduction. Road transportation. This one was actually interesting to me because we went back and forth over this a couple of times. I didn't really appreciate the difference in the efficiency of an electric vehicle compared to an internal combustion vehicle. I think the number that we finally got to was 2.5 times more efficient, right? 2.5 times more efficient. This is a significant improvement in energy efficiency. If we were to look at this from a cost perspective, that'd be something to consider as a significant approach to reducing the overall demand for energy use in transportation. And you can see in all cases, in Alberta, Ontario, and in Atlantic provinces, by the end of the time period, the amount of energy that's used for road transportation has dropped off dramatically. Commercial sector, you don't really see too much of a difference. The total demand moves from natural gas towards electricity, but the overall requirement here still is very similar. So what does that do in terms of the electricity markets in each of these three areas? Well, here's the first thing we have to keep in mind. If we're converting all these uses to electricity, we're going to need to generate that electricity somehow. Now, our analysis assumed a central grid delivery model. Now, of course, there's options for distributed generation, behind the meter generation, what have you. But from a simplistic perspective, what you'll be looking for is a grid in Ontario that's 2.5 times the size as it is right now that you would have to add. So imagine going to Ontario and saying, we're going to electrify everything, all our transportation, and instead of having one power plant in your region, we're going to have another 2.5. And instead of having one transmission line, we're going to have another 2.5. How are they going to like you then? We have a hard enough time citing anything these days. Here's one of the issues that we have to face if we're going to electrify our end uses. Where are we going to put it? If we go to completely microgrid systems, it's still going to be very expensive. And there's no way those microgrid systems are going to be able to handle the transportation sector. So what are we going to do? We're going to have major transmission lines along major highways. Something for us to think about. Alberta, we'd see 2 times, in addition to the footprint that we have right now for the electricity system, and in the Atlantic Canada it was 1.5 times. So what does that mean? Here we see some of the cost. What does it mean in terms of some of the emissions? Well, good news, right? We've got emissions in Alberta going down from about 40 million tons to 10 million tons. In the Atlantic Canada, that's from 15 million tons down to less than 5. In Ontario, it's over 60, and it comes down to below 20. So if you look at those in isolation of the industrial sector, that would seem to mean that we're on the right path. Well, maybe not. You have to include the industrial sector. Another key observation that comes out of our study is, although we're consumers, and a lot of the things that we do does require energy, unfortunately, the lion's share of that energy use and requirement is in the industrial sector that supports our current way of life. So regardless of where you are, whatever industrial sector you're using, whatever province you're in, whatever jurisdiction you're in, the industrial sector has to be part of the solution. And you can see here, for example, in terms of greenhouse gas emissions in Alberta, you're getting about a 5% reduction. In Atlantic Canada, it's a little more because the industrial sector is a smaller component, as well as Ontario. You're getting you're getting a smaller percentage reduction than you would in Alberta. What this really tells you is that anything we do in terms of greenhouse gas emissions needs to be fully comprehensive and involve all elements of our economy. So how much do these things cost? Who wants to know that? Okay, there's Alberta, all right? So business as usual, which is our base case, we're saying it's going to cost $59 billion over the time period to maintain the current approach to using electricity and gas and natural gas. If we were to electrify your residential and your commercial and your transportation sectors, we're looking at spending $133 billion. And guess what? That actually increases the emissions from Alberta. Anyone follow that through? Follow it through this way. What we've done is we've moved the less efficient consumption of fossil fuels, which were in the 70 to 85 range at the end use, and we brought them back to the generation unit, which is in the 50 to 55 range. So even though the end use is now almost 100% efficient, the overall system is less efficient, right? So another issue that needs to be dealt with. But when we add in gas with combined cycle, gas with carbon capture, we do get a reduction. And we get about a 10% reduction in the amount of emissions of greenhouse gases. Now, for that, we did a quick calculation, and that would cost about $112 per ton over that 30-year period. Right now, we're talking about a $20 per ton going to a $30 per ton in Alberta. We've got a $30 per ton in BC. We have the Ontario, Quebec, California program having market clearing prices of around $17 or $18 per ton. We have the feds at the far end at $50 per ton. This is $112 per ton. So that puts it into perspective. The other thing to keep in mind is in Alberta, what you would see also for the retail customer is about 110% increase in their retail bill under one scenario, and 100% increase in their retail bill in the other scenario. Now that's over a 30-year period, so of course it's not going to happen all at once. So let's say that it's about a 3% increase per year compared to business as usual. Now, what have we seen in Ontario? We've seen increases over the last 7 or 8 years in retail prices. They've gotten to the point where they're in the 50 to 75% range, and we see a significant number of people there very concerned about their electricity bill. So, Ontario, not so bad. We are seeing a cost of 600 billion going to a cost of 870 billion. And with the emissions reductions associated with that, we're seeing a cost per ton of about $200, much higher than what we've got here. Keep in mind a portion of their market that is still greenhouse gas emitting is smaller than Alberta. You got to keep in mind their hydro facilities as well as their nuclear facilities. And we're talking about a 45% increase in their retail price. And that's over and atop the numbers that they are seeing right now. In the Atlantic, we're looking at a little bit higher in the way of costs per ton, $225, and a 76% increase in electricity prices. In all 3 cases, what we're finding is that to implement this type of policy, you're going to see a significant increase in the end-use electricity price that people will have to pay, and a huge increase in the physical footprint of the electricity grid. So, electricity provides a viable option. Well, we can debate that one. We've seen that you can reduce emissions using a very broad-based set of policy changes that will affect each and every one of us. Everyone's got a home, everyone drives in a car or a bus. all of those will be affected. So what are we going to do about it? Just last night, there was an article on one of the news stories saying that people, there's a fair number of people, and I think they were just talking about Alberta, a fair number of people that are one paycheck or two paychecks away from some significant economic harm to their situation because they have very little money to manage any surprises. Okay, and now we're going to do this. And we're going to say, your furnace needs to be replaced. And we are going to be charging you 5% more this year for this electricity. And then next year we're going to charge you another 5%. And then the following year, the same. So, I've mentioned the fact about the cost. I've mentioned the fact about the footprint. I think I just want to end with this latter part right on the bottom here. It says deeper reductions require mitigation measures in the industrial sector, true, the freight transportation, and further decarbonization of the electricity sector. So what we're really looking at is taking this type of scheme to the extreme. So zero use of fossil fuels in people's homes, zero use of fossil fuels in people's commercial buildings, zero use with cars. And then, once you get to the grid itself, very little use of fossil fuels in the generation of electricity. Expensive, complicated, doable. Is it worth it? That's it. Any questions?
Hi. Just wondering, did you consider, replacing some of the airline travel with electrified high-speed rail?
The airline travel?
Yes.
No, we didn't do any freight or air traffic from that point of view. We just was ground transportation. We left the airlines alone.
For a lot of the short-haul air flights, right, they can be replaced with electric rail, right?
Oh, absolutely. Doesn't change the overall direction of what we're talking about here. You've got to keep in mind that air travel is not necessarily one of the larger end uses that we see. It's really industrial, commercial, and then residential.
Just two comments. One thing, I really appreciate the fact that we brought up moving people, and I think it'd be really interesting to start to see a little bit more discussion around moving people through public transportation systems, because I think that's where you're going to see the greatest traction in Alberta and Ontario and across Canada for uptake of electrification. But my comment.
Well, we can debate that if you want, because I don't necessarily agree with you on that.
Certainly, we'll take that offline. I'll meet you by the bike racks after school. If you wouldn't mind turning back to your slide number 23. You do talk a little bit about the embodied costs of transitioning to electrification. And I think it's really important to understand the situation that we have in Alberta, that the first and foremost, the idea of integrating renewables onto the grid and the cost of that doesn't necessarily need to be borne by the ratepayer. So we do have a different electricity system here in Alberta, and I know you guys understand the intricacies of that. But that's actually something that the Alberta Renewable Energy Program has really been focusing on, is ensuring that the ratepayer doesn't embody that cost, and that the source of funding to do that would come from from our carbon taxation or carbon levy program. So that's just one thing that I'd really like to encourage is before you release your research to talk about the implications of the funding source for where these dollars would come from, because that does actually play a very significant role in policy decisions that are made, as people would reference your study.
Well, it may make a difference in terms of what policymakers want to do. In terms of our analysis, it has no impact. We're not really there to suggest policy or make recommendations. What we are showing here is what the costs are going to be, how those costs are apportioned in the economy between citizens and companies. Is very much a political decision.
Certainly, I think just one last comment on that. I think the impact associated with costs when it comes down to renewables, depending on how the cost is structured, whether it's a ratepayer or not, does actually have an implication on what the actual total cost of integrating renewables would be. So I would throw a little bit more caution to the wind and say that I would consider that funding source does play a significant impact on what it would cost in total to integrate renewables into the system.
Well, let's be clear about the costs that you're talking about and the costs that I'm talking about. I think from what I'm understanding, your perspective is looking at the costs, the financial costs of investors or governments, whomever. I'm looking at the economic costs to society. And in those situations, those costs will be the same regardless of who bears them.
Hi there. Just wondering if within any of your scenarios, whether you considered the incent in Alberta, it's a good slide for me, whether we incent current generators to go cogen and whether or not that's included in the scenario.
Well, for that, I'd have to get my big brain to answer that question. Ganesh, did we include cogen?
All like full change over to cogen.
Well, industrial generation turn over to cogen. But the issue there is cogen will still be natural gas power generation. So in order to get significant reductions over economy, you also have to clean up the grid. So cogen by itself wouldn't do that because you can get to the 50%, midway point, but you have to go further if you want to get at least 10% reduction across the economy. So you have to do more than that. Maybe like another way of looking at that is then not just cogen, but maybe cogen with carbon capture.
Hi, Joe here. I was actually at Ganesh's talk a couple of weeks ago at the University of Calgary. Thanks, Ganesh. I just want to mention that when you create a model, there's a bunch of assumptions that go into that model. And some of the assumptions that you've made is that distributed energy is not going to play a role, that storage isn't going to become a role. You have also mentioned that freight and industrial aren't included. So those are the assumptions that you've mentioned, but there's a couple of assumptions you haven't mentioned. The first is that CO2 price isn't going to affect consumer choices and consumer decisions as far as the time of the rollover of some of these things.
That's
and
correct.
What's going to be chosen. You also haven't mentioned that your assumptions regarding the cost of renewable energy. And I know that Ganesh said in his presentation that the assumptions that he had made, at least at that time, was that those costs were going to go up. So basically, as time went on, solar was going to get more expensive and wind's going to get more expensive. And the actual reality is that they're plummeting, and all the forecasts say that they're going to drop further. So I think there's a lot of assumptions that are going on. You're basically making the case that we shouldn't do anything. We should maintain the status quo for as long as possible, and I'm just questioning that.
Actually, no, we're not making the case for that. What we're making the case for is go in with your eyes open.
With a bunch of false assumptions.
Well, okay. Right. It's fair to say that assumptions are those elements in a methodology that people use to either simplify or streamline their analysis. if those assumptions are not agreed to by other people, that's fine. That's all what research is about. I'm sure there's people all over this world that don't agree with the assumptions of their colleagues. And if you are looking for something that suggests, you know, where the prices should go versus where they've been, that's going to be a guess too. And we also have to keep in mind that as we change our use of these technologies, we will find different things that we didn't appreciate before. Right now, they're being used in very more ideal circumstances than they would if they were put in general use. Another assumption of mine. So you, of course, can take an alternative view to that. And when we put our assumptions in there and we state what we're talking about in terms of cost and physical impact and disruptions on the economy, that's not to say that we shouldn't do it. But what I don't think we should do is say, let's electrify, and that's the end of the conversation. And that's the kind of conversation we've been having so far. It's just like saying, let's go take that hill. We don't know who's on the other side of it. If we get to the top of it, there may be a whole bunch of people that are out there to get us, and that was the wrong thing to do. Well, maybe you should send someone up ahead and have a look over the hill before you send them up. And that's all we're doing.
I'd like to thank you very much for the presentation. I also, as with Joe, went to the university presentation, and I had to come back because what I saw then just drove me to come back and look at this again. So, as an unemployed petroleum engineer with 3 kids, if I go to Aberdeen and talk to my employed petroleum engineer colleague with 3 kids, and I walk into his house, I notice 2 things. One, he's got a programmable thermostat, which allows him to determine at what point in the day his heat's on and off. And number 2, he has a radiator in every room of his house that also has a thermostat that allows him to control the temperature of every room. Whereas I, until recently, didn't have a programmable thermostat, and I still can't control the temperature of each room in my house. And I would therefore suggest, as a good practical engineer, that conservation and efficiency are 2 key things which will reduce people's electricity consumption with their existing technology, right?
Yes.
And that's worthwhile considering, because if
Yes.
it takes the government $112 a ton for their CO2 before they have any impact on people's behavior, they're not going to get there soon. So we can take sooner steps, faster, more efficiently, but don't have me pay more tax. I don't want to be paying a carbon tax if somebody's not taking off my income tax at the other end. And I speak on behalf of all the employed people and not the unemployed, so thank you for your time.
Well, it's hard to respond to that one. I mean, it's fair to say that there are a lot of approaches that people can take that are not as intrusive as what we're talking about here with respect to their own use. And you can bring, you know, the efficiency use in your homes down by 20 to 25%. You can do 30 to 35% for commercial and 40 to 50% for industrial. All right, that's still not going to get us where we need to go. So this is another element associated with going that route. But the other thing to keep in mind, if you are moving towards the energy efficiency element of your natural gas or gasoline units, the first time you actually replace those with something that just uses electricity, that investment that you've made in natural gas energy efficiency is no longer valuable because you've just gone a sidestep away from that type of technology.
So we've gone a bit longer, so I'm going to cut it off there because we're right at time. People need to get back to work.
Okay.
I want to mention that in December we're going to have Todd Hirsch come out and talk about some of the economic realities that we face in Alberta. and what do some of the changes mean economically for our province. I also want to thank Alan and CERI. You've elicited a lot of critical thinking, and that is a good thing. We need to all say, what's my part, what can I do, and critically think through these challenges going forward that face us. So please join me in thanking Alan Fogwell.